Hello and welcome to this video on the property of materials. The property of materials really are how a material reacts to the environment that it's put in. So I suppose the environment that a material is put in can be broken down into two different parts. So one might be the forces that are applied to that, because most things that are engineered from materials will have forces applied to them. So that force might be, there's four common types of forces. That force might be tensile force, or when the piece of material is put in tension. That's a fancy way of saying when the material is pulled apart from one end and pulled the other direction from the other. So it's in tension and it's being pulled. One of those forces might be compression. That means when the material is being squeezed together, squished, squeezed, pushed together from opposite ends. Another force might be shear. An example of shear will be taking a piece of material, and at one point, a plane, so at one point, a very flat surface, at one point, pushing one direction, pushing the material one direction one way, and then just like below that, pushing the material in the opposite direction. A really good example of shear would be a scissors. So you can imagine a scissors, two steel blades, and they both are going in opposite directions, and as a result they have a cutting force. And the last force there would be torsion or twisting force. So as a twisting force, basically a piece of material will be twisted, and the ability of a material to withstand any of these forces will be one of its properties. Okay, so bear that in mind in terms of all the types of forces. So you really have to know the four types of forces to be able to understand the properties of materials. The mechanical properties of materials. So if I took a material and I was to subject it to a force, I would be basically carrying out a mechanical operation on that material. So the mechanical properties of materials, there's a number of them, and they are basically when they are subjected to then types of forces. So for example, malleability. 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 It's a word we have to learn to know how to spell, and it's a word we need to be able to know the meaning of. It basically means that malleability is the ability of a material to be hammered, pressed, or rolled into thin sheets without rupture. So gold is an example of the most malleable metal. You can see here a piece of ancient Irish jewellery where the gold has been hammered into a thin sheet and formed into like a necklace, and you can see two decorative brooches either side of the necklace. So the gold would have come in a nugget form, as you can see in the picture on the left hand side, and it would have been hammered and beaten into a flat sheet that you can see here. So it's very malleable. So once you put a compressive force or a press down it squeezes out in all directions. So it can be hammered, pressed, or rolled into thin sheets without breaking, without rupture. Okay. Ductility. This is the ability of a metal to undergo plastic deformation without fracture. And that's a very fancy term. So what does that really mean? Look down the bottom, which is the broken down example. Ductility is the ability of a material to be stretched, pulled without rupture or breaking. So you can see here on the diagram on the right hand side, we have a tungsten carbide die. And if we take the tungsten carbide, it's a really, really, really hard material, really strong material. And I used to take basically I put a hole into that. A die is something with a hole in it that you press something through and it creates a shape. Think of maybe Play-Doh, and where you want to get a shape in Play-Doh, you get a piece of Play-Doh, put it at the back of it and push it through a hole and it will come out the same shape as it. So you might have a star, a hexagon, or a circle, whatever. Here you see the example where you have tungsten carbide die, so it's a really, really strong die. And then we have the shape in the middle of that, which is a hole. So everything's going to pop through that. It's going to come out in the shape of that hole. And we take a piece of copper and we push that piece of copper through that hole with a great amount of pressure. That copper bar can be pulled through the die and its diameter is reduced to make a very thin wire. So, for example, most of the wire that you would see in your house, in any electronics that you use, will be made from copper. And if it's a pair of headphones or a charger cable or whatever, there could be 5 or 6 cables in that, small wires in that, and you can imagine that all those pieces of copper have to be made down to a really, really small size. So that's an example of ductility. Copper is a very good example of ductility. It's a very ductile metal. It can be stretched, pulled without breaking. If we look here, we look at hardness. Okay, so hardness. Hardness is the ability of material to withstand wear, scratching, or indentation. So we just look at the video on the right, I suppose. Here's a video of, I think it's Jerry Rig Everything, the YouTuber, and he's using a scraper or a scratcher to test the hardness of new phone's glass. So it's meant to have a ceramic coating which prevents scratching. So he's put a scale on top and has basically taken different types of materials of scrapers and ran them across the top. So each material will have a different, each one of the tips of his pen there is made of a different material, which is harder, which will actually dig into the material on the phone cover a lot easier. So we can see there, you can see as he scrapes down through 2, 3, 4, 5, 6, 7, 8, 9, we can see when he turns the phone off in a second, you'll see the different types of scrapes. So that's testing the hardness of the phone glass or the phone cover. Okay, so you can see it there, there's some scrapes and scratches up here. That's the scratching and wear. Indentation, if you look at the diagram on the left hand side, you can see a center punch being hammered into a soft piece of material, and we can see that the material deforms or breaks or takes a different shape, and the softer the material, the more of a shape it'll take. The harder the material, the less likely it will to be indented. So again, hardness is the ability of material to withstand wear, scratching, and indentation, and a good example of this will be cast iron. Toughness. Toughness is the ability of a material to withstand blows and impacts. So if you look from the picture there on the right hand side, we can see that a blacksmith is basically working a piece of wrought iron, and he's hammering it with a hammer. So he heats it up so it's nice and soft, nice and malleable, and he's using a hammer to hammer into a shape. So you can see that he's flattening it down there and making it into a thinner shape. And a good example of, but he's hammered on top of a thing called an anvil, and the anvil is made of a very, very tough material, so it can withstand the blows and the impacts of the hammer and the piece of material on top of it. That anvil will be made from high carbon steel, so it's a very good example of tough material. So toughness is the ability of material to withstand blows and impacts. Brittleness. Brittleness is the opposite of toughness, and brittleness is when a material fractures or breaks easily and shatters easily. Okay, so if you look at the example here, this is an example of a piece of glass. So if you can imagine the blacksmith's hammer that he's using there, if you were to take that hammer and touch it off a piece of glass, hit it the same effort as what you would with a piece of steel in the previous slide, the glass would shatter into a million pieces. So the glass would be very brittle, so it's not able to withstand blows and impacts. As a matter of fact, when material gets, when glass or is hit, it's a very brittle material and so fractures very easily. Strength. So strength is defined as the ability of a material to withstand tension, compression, torsion, and shear. So if you remember back to the start of the video, we had all those forces, 4 different types of forces being applied to it. So a material that's able to withstand those 4 forces is said to be very strong or has high strength properties. So an example of that would be steel. Elasticity. So elasticity is the ability of a material to resume its original shape after it's been stretched, pushed, or twisted. So if you were to take an example here, we can see that this material, the top picture here, is just a test piece, and it's been pulled, and we can see the force being applied to it in the second one, and it has lengthened. So it's plastic deformation. It is pulled out. But when you take the force away from it, it returns to its original condition, original shape. So an example of that would be if you had an elastic band or a rubber band, you were to pull the rubber band apart, and when you let go, it will go to its original length. Okay. Lots of metals would have a certain amount of elasticity, so you would be able to pull them, not for as long as you'd be able to pull a rubber band. Maybe you might be able to pull them for 0.5 millimeter, 1/4 millimeter, and they would return to the original shape. So they have a certain amount of elasticity. If you think of like a marshmallow, if you were to take a marshmallow and twist the marshmallow, let it go, it'll go back to its original shape. Now, if you twist it past its point of elasticity, that most materials then will have an element of plasticity. So plasticity is the ability of material to keep its shape after it has been bent, twisted, stretched, or squeezed. So if you apply a load to material and it keeps that shape, even when the load has been removed or this force has been removed, that material is said to be plastic or has plasticity towards that material. A good example of this would be polycarbonate. So polycarbonate is a very good example of plasticity. You can take a piece of polycarbonate, you can bend it, and it will retain the shape without applying heat or anything like that. Again, if you were to take I said a marshmallow on the last slide, we're talking about elasticity. If you take a Mars bar, you have to twist the Mars bar will keep the shape without breaking. So you twist maybe 90 degrees, it'll not actually break. If you twist it more than 90 degrees, of course it'll break, but there's a point there whereby it'll actually move and it'll keep the shape. So that's plasticity. Those are the mechanical properties of materials. There's also a thing called the chemical properties. So chemical properties is exactly what it says. It changes the chemistry of the material. So conductivity. Conductivity is the ability of material to allow heat or electricity to flow through it. So we mentioned copper wire already. Copper is a very good conductor. It allows electricity to flow through it, so that's why most of the wires that we know in our house are made from copper. Also allows you to conduct heat very efficiently through it. So if you were to take a lot of pipe work and a lot of heating coils and that will be made from copper as well, because it's very efficient in terms of heating. So conductivity is the ability of material to allow heat or electricity to flow through it. The opposite of that will be insulation. So if you have your copper wire with your electricity flowing through it and it's at the end of your plug, you put your hand in the plug and you don't get electrocuted. So part of that reason is it's surrounded by plastic, and plastic has good insulation properties. So the insulation properties of material prevent electricity and heat from flowing through it. The same can be said for the coffee cup, made from material, a plastic material, probably expanded polystyrene. If you were to take that coffee cup, pour boiling hot water into it, it would insulate the boiling hot water's heat from your hand, so it wouldn't burn you. So insulation prevents heat travelling through from one material to the next. Corrosion. Corrosion is when a metal reacts to the environment, usually the air, the water in the environment, to make a new material. So for example, we can see here in this picture in the top right hand corner, we would call that rust. Now rust is what happens when corrosion occurs to a piece of steel or a piece of iron. So the iron in a piece of iron or the iron in a piece of steel reacts with the water or the air in the air around us, and it basically forms a new material called iron oxide. That iron oxide is a really flaky red material, so you can see it there. What will happen is over time more and more iron oxide will be created, and to create that iron oxide they'll have to take a little bit of iron away from the surface each time. So it robs a bit of iron each time, it makes new iron oxide from the surface, and as a result it'll make it weaker, create holes in it and so on. Okay, not necessarily have to be iron for it to corrode. You can see here an example of a copper roof on a church. Copper roofs are common on older buildings or on buildings that are fairly architecturally sound. If you look here, this copper roof is on a church and it has corroded. Now, copper oxide turns green. So copper is a brown material, or a dark brown, or a golden material, dark golden material. And when it's exposed to the air, the water in the air, it turns green. So some people like it for making it look good, or good aesthetics is what they call it when it looks good. So there's an example there of a copper roof which has been oxidized through the air. Okay, so that's the end of our video. Remember, to know the properties of material, you must know the forces that are issued on it. So tension, compression, shear and torsion. We need to know mechanical properties of material, so malleability, ductility, hardness, toughness, brittleness. Then we need to know the chemical properties of material, so its ability to be conductive, be an insulator, and then its ability to corrode. So if you're to know all that about materials, you have a very good knowledge of most materials and how they apply to a situation. For example, if you wanted a material that was a very good conductor, but very also had strong properties, well then you mightn't go for copper, because copper would be very good conductor, however wouldn't be very strong. So then we would look up the list of which one was a good, which material would be a good conductor but also strong. So it's about trying to find the best fit for each material. Okay, that's the end of the video. Thanks for watching.